In this lesson, you will learn about synthetic polymers. Unlike natural polymers, these polymers are made by humans in a factory instead of within a living organism. You are likely familiar with the term plastics. This is a broad term encompassing a wide range of polymers made of monomers derived from crude oil. Crude oil is known as a non-renewable resource because we cannot grow or produce crude oil. The fractions obtained from the fractional distillation of crude oil can be cracked to form alkenes, some of which are the monomers of these synthetic polymers. For example, polyethylene, also known as polyethylene, is a polymer of ethene monomers. These polyethylene polymers can be high or low density, all depending on the degree of branching present. The term branch refers to smaller chains sticking out of the main chain, much like branches on a tree. Polypropene or polypropylene is a polymer of propene monomers. Polyvinyl chloride or PVC is a polymer of chloroethene or vinyl chloride monomers. Can you predict the name of the monomer of polytetrafluoroethylene, PTFE? Pause, think, and resume when ready. The answer is tetrafluoroethylene. Polystyrene is synthesized from the polymerization of styrene monomers. You may have encountered polystyrene as white cups in food packaging materials. Expanded polystyrene is used in packaging and shipping, so to protect the contents from being damaged. Since our other videos discuss these synthetic polymers and their uses in great detail, we will focus on other useful synthetic polymers. Regular school glue, or PVA glue, is polyvinyl acetate, a synthetic polymer made from repeating units of vinyl acetate monomers. When you lick a stamp to stick it on an envelope, and when you lick the edges of the envelope to seal it, that sticky part is actually made of polyvinyl acetate. Ethyl cyanoacrylic polymerizes to form a very strong adhesive, much stronger than PVA glue. This very strong glue is known as superglue. Soft drink bottles are made of polyethylene terephthalate. If you look near the bottom of the bottle, you will see this sign. This means that it can be recycled, which means that it can be broken apart into their respective monomers and polymerized once again. This is important because it reduces the amount of waste in landfills. Imagine if these synthetic polymers could not be recycled. All the soft drink bottle waste, plastic containers, and certain packaging materials would just accumulate. With the global population expanding at an exponential rate, without a good recycling scheme in place, this could become a very serious environmental and social issue. An increasingly important synthetic polymer is polylactic acid, or PLA, used to make plastic cups and other packaging materials. This is a polymer of lactic acid, which is obtained from the bacterial fermentation of carbohydrates. These sugars can come from corn or sugarcane, all of which are renewable resources because they can be grown again and again. If you exercise for an extended amount of time, your muscles begin to cramp. This is due to the production of lactic acid from insufficient oxygen in your muscle cells. Besides being derived from a renewable resource, PLA is also biodegradable. In other words, it can break down naturally. PLA is sometimes used in the medical field as dissolvable stitches. If you had to get stitches, you wouldn't have to return to the clinic or hospital to have them removed because they biodegrade naturally over time. Another synthetic polymer, with this real-life application is polyglycolic acid. Imagine if we can one day dispose a food container in our garden and find that it has decomposed in a few days. Imagine if we can recycle a soft drink bottle in our own home. The possibilities are endless, all with the intent to reduce the impact of mass production of waste on our planet. In summary, there are many synthetic polymers with many real-life applications, and in particular, there is an increased interest in recyclable and biodegradable synthetic polymers.